Chapter 2 is all about functions and what we can do with them. So on yesterday, we did 2.1, which was the increasing, decreasing, max and min, and piecewise functions. So it's all these kind of properties of functions. Today, what we're going to do is we're going to do math with functions, meaning we're going to add, subtract, multiply, and divide functions to make new functions, all right? And it's pretty self-explanatory. If we remember what like terms are, remember like terms are when the variable look the same and the exponent looks the same. Then you can just combine them, and you just do the math with the coefficient, and then the variable stays the same, right? Like 3x squared plus 5x squared is 8x squared. So just kind of keep that in mind when we go through it. So it says, objective 1, we're going to find the sum, meaning we're going to add. We're going to find the difference, meaning we're going to subtract. We're going to find the product, meaning we're going to multiply, and the quotient of all two functions to come up with a new function. That part's the easy part. The hard part, guys, is once we come up with that new function, stating the new functions domain, okay? So it says domains of f plus g, f minus g, f of g, and f divided by g. Let's look at the instructions. It says, if f and g are functions, then the domain of the first three things, so add, subtract, multiply, and divide, the domain of these three operations is the intersection of the domains of f and g. What's it mean for something to intersect? Goes through, right? It's what they share. It's what they have in common, okay? Values they share. The reason why the domain of f divided by g is a little bit different, so it starts with the intersection, but since we're doing division, what do we never want on the bottom? The 0, right? So that's the key thing. So notice the domain of f divided by g. So the domain of f divided by g is still the intersection like we did before, but then we got to knock out any x values that potentially make the denominator 0, okay? So if any question asks you, okay, here's f, here's g, find the domain, I find the new function first and then find the domain. I think that's easier than trying to follow all this jazz, okay? So let's just jump right in. Example 1 gave us two functions. X squared plus 2 is f of x. X minus 3 is g of x. And we're going to do plus, minus, multiply, divide. We're going to get all those new functions, okay? Then we'll start talking about the domains, all right? So I'm actually going to go down here and figure out, I think it's easier just to do it, okay, versus doing the domain first, okay? So let me jump down here first, and then we'll go back to A. So I'm trying to pull that out so it's higher. There you go. All right, so let's find what f of g of x is. So notice up here, I kind of skipped over it, I'm sorry. F plus g is a function, but how you find it is literally f of x plus g of x, okay? So anytime we see it like spread out like that, I rewrite it as f of x minus g of x, okay? The key thing with subtraction is that however you plug in f, however you plug in g, make sure g, the back function, has parentheses around it, so when we have that negative in front, we're going to distribute that negative to all of g, okay? So how do we write this? I technically write it with both sets of parentheses, x squared plus 2 minus x minus 3. Do you guys see where I got those two values? Because what was f of x? X squared plus 2 minus g of x, but what was g of x? X minus 3. At that point, once you plug them into where they need to go, we're going to just get rid of parentheses. Did I really need these parentheses here? No. So I'm just going to write them as x squared plus 2. But in order to get rid of the second set of parentheses, what do I need to do with my negative? Distribute it, right? So it'll make my x negative, but what will it do to my 3? Make it positive? Is that okay? And that's why I said it's important to have parentheses around the whole thing, so you know not just that front number, that front term's negative, all of it changes signs. All right, at this point, guys, all we do is collect like terms. Are there any other x squares to combine with the x squared? No. No, so it's going to stay x squared. Is there any other x's to combine with that x? No. Nope. And then can we combine our constants? Yes. A positive 2 plus a positive 3 will give us a plus 5. And you guys just found f minus g of x. And what it made, I know we haven't really talked about this, but whenever you have a squared term, that's called a parabola, so its graph would be a parabola, and this is a line. It's kind of weird to think, okay, if you take a parabola and subtract a line from it, that's like what we're doing, you get a new parabola. It's kind of interesting, all right? So let's do the next one, C, and then we'll go back to do A, and we'll talk about why the answer is what it is based on B and C, okay? So what is C? C, guys, is usually the easiest one because it's literally f of x divided by g of x, and there's rarely anything you can do other than put f over g. That's all we're doing, okay? So what was f of x? X squared plus 2. What was g of x? X minus 3. And that's all we can do. We can't cross out that x with the x squared because it's not really x, that's x minus whatever 3 is, right? So like, say x was 0, that's 2 over negative 3. Say x was 1, that's 3 over negative 2. You know what I mean? It's not going to cross out perfectly. So unless it factors to where it can cross out, you're just done, okay? So the division part, as far as coming up with the new function, is easy. The domain's a little tricky, though. Okay, so let's go back up to here, the rules and what it was saying. It said f plus g, f minus g, and f times g will always just be the intersection of these two domains. So let's just talk about those two domains. What is the domain of f of x? Well, let's look at f of x. I don't know if you remember this because it's been a while since we talked about domains, but domains are all x values you can plug in there. Can you plug a negative in for x into f? Yeah? Can you plug a positive? Yeah. Can you plug in small numbers? Yeah. Can you plug in big numbers? Yeah. There's no restrictions, right? Remember there was two, do you remember the two restrictions we had to be careful about? No zero on the denominator and no negatives in an even root. Those are the only two where we have restrictions. So everything else, a parabola, a line, they're all going to have what domain? All real numbers, negative infinity to positive infinity. So knowing that, what's the domain of g of x? He's a line, so he's the same, right? Are there any restrictions on what we can plug in for x? No, it can be positive, it can be negative, it can be big or small. It's just a line. It goes on forever, right? So its domain is negative infinity to positive infinity, okay? So, knowing that, let's go back to this definition up here and see if it can make sense. It says if f and g are functions, which they are, then the domain of these three new functions is just the intersection or the values that f and g share. But aren't they just the same exact domains? Yeah, what do they share? Everything, right? So the domain of f plus g, f minus g, and f times g is just what? Negative infinity to positive infinity. Okay? Why is the domain of f divided by g a little bit different? Because we can't have a 0 down there. So what do we have to do? We have to consider this guy, right? He has all real numbers by himself. Oh, I'm kind of low, sorry. I'm like pointing to stuff you can't see. He can be any numbers. He can be any number if he's by himself, but we have to figure out what don't we want x to be to make that denominator 0. We don't want it to be 3, right? So x can't equal 3, right? But that's not the domain. That's what's hard. It's like, usually we find those values that don't work, and you want to say that's your domain. No, domain is what can work. So we have to say all numbers but the number 3. So do you remember how to do it with interval notation? You start at negative infinity and you stop where you have that hole that you have to jump over, and you always use a parenthesis, the union. We're going to jump right over that 3 and keep on going. So we just answered A. And like I said, you really probably could do the first part, the f plus g, the f minus g, the f times g, without figuring it out. But I like to actually figure out what f over g is so I can physically see with my own eyes what I'm worried about being 0, okay? Because if you try to think of it logically, sometimes you're like, well, what one's going to be on the bottom and what, you know. So just figure out what f over g is, and then you can easily find that restriction, okay? So what is the point of this? I just realized when I made the notes, I copied them, I made the worksheet, I copied them, and I realized we have a couple problems on our worksheet that we didn't do on the notes, but I'm going to talk about it now, and I'd be more than happy to talk about it again on the worksheet. We came up with a new function. So like f minus g of x is a new function, meaning you can plug in x values into this new function. What do I mean by that? on your worksheet, it will give you f, it will give you g, and it'll ask you to find f minus g of 3. What do you think you need to do? You find f minus g and then do what with 3? Put it in for x, okay? So just kind of bear with me because I wish I would have put a couple examples like that on our notes where you can find this new function and you leave it generic with x, but you can also find that new function and plug in that value of 3, okay? This next part, if I don't like to use the word haunt, but this is going to be what haunts you through the rest of the semester. It's probably one of the most important things you'll do in here as far as moving on to other math classes. So most of you who are in college algebra usually need to go on. It rarely qualifies for your college math. Like you're usually going on to trig and calculus and so forth. So this difference quotient is actually something that you do the first chapter of calculus. So we're doing calculus right now, which is pretty cool, okay? So let's see what it says. It says the ratio below is called the difference quotient or average rate of change. Difference because we're subtracting, quotient because we're dividing. And all it's doing is it's trying to find slope. Remember, average rate of change was another way to say slope? But it's a way to find slope generically, because we know how to find slope of a line. For example, right here, guys, you can tell me what the slope is of this line. What's the slope of this line? 5. But if we have a parabola and I want to know the slope of the parabola, it's not that easy, right? So if it's any function other than a line, figuring out the slope is kind of difficult. So guess what we can always do? Find the difference quotient. Okay, so you're going to be a little artist right now. Is anybody good at drawing? Because I'm not. Okay, so what we're going to do is we're going to draw like this little arch, kind of like a half parabola going on here, guys. And we're going to label it. Okay, I probably just, what'd you say?
Is it just one?
Yeah, just one graph. So one, yeah, you're okay to take up the whole thing. I probably should have had it on here. I needed to start doing that, like copy and paste like pictures and put. It's harder than you think sometimes because of copyrights. But okay, so on this graph, guys, randomly pick a spot over here somewhere on the left and mark it X. Okay. So what does that mean for our point on the graph? Well, it's generic, right? So what is the X value? X. But what's a way to show the Y value? Not Y, but when we want it to show that it's a function, we say f of x. Do you guys agree? Is that okay? So remember, whenever you have an ordered pair, the x value is x. So in this case, since x is what we're using, that's the x value. And the y value is just f of whatever. So if that's 3, it's f of 3, right? So what the whole idea of difference quotient is, it's a way to find slope between 2 points that are kind of close. So we'll make a point over here. And down here on the x-axis, we're going to call it x plus h. Meaning I went from x to x plus h. I gained h units, right? And the whole idea, and I know right now it's going to be kind of over your head, but the whole idea of calculus is you want to be able to find the slope at one point, and that seems physically impossible, right? Because what do we need? We need 2 points to make a slope, to use a slope formula. So you kind of start doing the impossible with this. So the whole idea, again, I'm kind of getting ahead of us, but in calculus, the whole idea is you have x, and then you just add a little bit, you add h, but you want to make h smaller and smaller and smaller and smaller, and that's what you start doing in calculus. So it's basically right next to x. It's basically 1 point, and you're able to find a slope at 1 point, which seems impossible. Okay, let's label this right here. What is the x value that we're at? X plus h. He looks ugly, but that's him. So what does that leave the y value to be, guys? You got it. Again, looks weird, right? So the whole idea of difference quotient is that we're going to use these 2 values to find a slope, an average rate of change. What'd you say? It's a lot of variables, and so it's weird to do it like generically with variables. But think of the slope formula. I'm going to write the slope formula over here. Remember that slope formula from last week, I think is when we covered it? All right, so say this is my second point. What is the y value for my second point? F of x plus h. What do I have in the difference quotient? F of x plus h. Minus the y value of my first point. If this is my first point, what's its y value? f of x. So notice that's just my second y minus my y. How do we just get h on the bottom? Well, we'll kind of do the math down here. What was my second x? X plus h minus my first x, which was just, and the x's cancel out, right? Do you guys see that? Because this x is positive, this x is negative, and it leaves you with h. So the difference quotient is just the formula for slope with two very generic points. That's all it is. Even more generic than xy, x1, y1, y1, x1 or x2, y2. All right. So I like to do it with example 2 first because it proves to you what we already know. Would I ever use the difference quotient in real life to find the slope of a line? No, because we just know. Where's the slope always located? In front of your variable, right? So we know the slope is 5. Does everybody agree? We're going to use the difference quotient to prove that works, okay? So how do we do the difference quotients? What I do is I already know what f of x is. It's 5x minus 1. I already know what h is. It's just h. What I don't know is what f of x plus h is. And this is why we had that one section where we evaluated 3x, x minus 1, that kind of stuff, right? Wherever I see x in this function, I'm going to plug in what? X plus h, right? So I have 5 times x, so really I'm going to have 5 times what? X plus h minus 1, like that. Is that okay so far? So what do you think our next move is, just so we can kind of have it cleaner and we can do math with it? Distribute. You rarely want to keep parentheses there when you're trying to compute, okay? So we're going to distribute the 5 here and the 5 here. So that leaves us with 5x plus 5h minus 1. So guess what we just found, guys? We just found what f of x plus h is. If f is 5x minus 1, f of x plus h is 5x plus 5h minus 1. So, ... we can do the difference formula, right? I'm going to write it generically, f of x plus h minus f of x all over h. Because the more we can write it generically, guys, the more we'll have memorized. This is one that I will give to you on the first exam, maybe even the second exam. By the time we get to the 4th exam, you'll have it memorized. Or you'll have to at least get it memorized. Okay, so don't we know what f of x plus h is? Yeah. We just found it, right? So it's going to go straight down there. So we're going to have 5x plus 5h minus 1. Is that okay so far? I just put him. And then what do I want to do? I want to subtract f of x. But what do I need to make sure I do with f of x? Put them in parentheses, because I want to subtract all of him. If you know that's what we're doing, if you know, okay, I'm subtracting all of it, and you just want to leave out the parentheses and change all your signs as you write f of x down, you can. So you might say, I know this is going to be minus 5x plus 1, because I'm going to distribute that negative eventually. And this is all over what? H. All right. So my next move is to distribute. So I'll have 5x plus 5h minus 1 minus 5x plus 1. Is that okay? Yeah. All over h. Oh, I'm writing off. Yeah, it's like really zoomed in. Sorry. This might help you too. Does that look a little bit better so we can see the whole page? Yeah. And then that's all over h. I'm kind of running out of room, but like we're basically done. If you're doing it correctly, everything should cancel out except our 5. Right? The whole idea of this difference quotient is to find your slope. We're going to be able to find our slope. So I just start left to right. Is there anything that can cancel out with this positive 5x? Yeah. Yep. The negative 5x over here. Is there anything right now that can cancel out with the 5h? No. So just leave him alone. He's okay. Is there anything to cancel out with a negative 1? The positive 1. So what are we left with, guys? 5h over h. The h's cancel out. The h will cancel out. Yep. It'll just be 5. We just proved how to find slope.
That's so tedious.
It is. So that's why, like, in real life, I'm like, oh, what's the slope of this? I don't expect you guys to say, well, let me get the difference quotient out for this line. But we do have to use it for 3 and 4 because we don't have a simple thing yet. I will show you real quickly. Number 3 is not hard to do if you just know the trick. So I'm going to teach you calculus. Have you anybody heard the word derivative before? No. In calculus? Okay. So one of the very first things you learn in calculus is derivatives, and that's the slope of the tangent line, and that's technically what we're finding. Okay? So what we're going to do is we're going to use this different quotient for that as well. I try to give us a little bit more room on this one just because it's a little bit bigger of a function. I'm going to do it the long way with you. And then once we get the answer, I'm going to point out to you where you can kind of see it in your original guy, okay? Just like we can see 5 in our original. Okay. So right above it, or right here, I'm going to find, we know f of x, we know h, we got to find f of x plus h. So your first move is always to put x plus h in to your function to figure out x plus h is. I got 10 minutes, guys, okay, on this. So we have x plus h, the quantity squared, plus 2 times x plus h minus 3. Is that okay? So my function was x squared, but instead of x, I want x plus h. So I put x plus h, the quantity squared, plus 2 times what x is, but my x is x plus h. So I put in x plus h. And then your constant always just stays your constant, minus 3. There's nothing to do there. What we have to be careful of, I was grading some papers, and some people just want to make this x squared h squared. Remember, that's not true. It's x plus h times x plus h, right? So we actually are going to have to FOIL this guy. Oh, yeah, you thought foiling was bad? Now put FOIL with random letters, right? There's no numbers anywhere, all right? This next part, though, guys, I'm just going to distribute the 2. That's all I need to do there, right? So that will just be 2x plus 2h, and then minus 3. All right, so I'm going to help you with the FOIL. We're going to have x times x. What will that be? X squared. X squared. Is that okay? Then we're going to take x times h. What will that just be? As easy as it sounds. xh, right? Like if that was x times 3, it was 3x, right? But it's just x times h. We don't need either one, so we'll just stay x times h. All right, so I'm done with this x. I made x times x, x squared, and x times h, xh. So I'm done with him. So I'm going to move on to the h. What's h times x? hx, but what's a better way to write it? xh, right? So remember, multiplication is commutative, and if you notice something where they're going to match pending the order you write them in the order where they match, right? And then what's h times h? You got it. And then the rest is just plus 2x plus 2h minus 3. Holy moly. That is the function x squared plus 2x minus 3 with x plus h as our x, okay? So instead of rewriting this because it's just going to mess up room, we'll just jump right in. What's the very first thing of our difference formula? That function we just found, right? So that really long function we just found right here is the first part of our difference formula. So we're going to just plug it in. X squared plus xh plus xh plus h squared plus 2x plus 2h minus 3. So that is just the f of x plus h part. What do we still need to do? Subtract f of x. What was f of x? That original function that I put my arrows all over, right? Minus x squared plus 2x minus 3. All of that, believe it or not, most of it's going to cancel, which is weird, okay? And this is all over h. Don't forget about him, okay? So we had ultimately wanted to combine like terms and usually just cross things out, right? So I need to get this negative to distribute. So, is there anything we can cross out yet? Nope, but there's something I can combine. Okay, so let's write x squared. We'll write it kind of small because we're running out of room over here. What can we do with these two terms? These two. They're not going to cancel because they have the same sign. Add up to 2 of them, right? You have one xh and another xh. How many xh's do you have? 2xh. And then we'll have plus h squared plus 2x plus 2h, I'm running out of room, minus 3 minus x squared minus 2x plus 6. And I kind of ran out of room, guys. I'm sorry that's like I had to go on a different level there. So these are all on the same level. I just write too large. All right, start canceling things out. Do you guys notice this x squared term is going to cancel out with this negative x squared term? So, and wherever yours might be, okay? There's nothing that's going to cancel out with our 2xh for now. Nothing that cancels out with our h squared for now. But what about this 2x here?
The negative 2x.
And the negative 2x there. And then, oh, did you guys question why that's on a 6? I'm sorry. Like, where did the 6 come from? I'm sorry about that. It's just a positive 3 there, right? Because all I had right here was a negative distributing to a negative 3. So that should just be a plus 3, right? So now, what do you notice about our constants? They're going to cancel. So when things don't cancel out so perfectly, go back and check your math. So I'm like, when I saw that 6 not cancel out with a negative 3, I'm like, what did I do wrong? Okay. So let's write what we have left. We have
2xh plus h.
yeah, so we have 2xh plus h squared plus 2h. Does that look right?
Yeah. Actually,
I know, so we haven't got rid of him, and then we haven't gotten rid of that 2h. All right. Any ideas what we should do next?
The h's okay.
The h's will cancel out, but we can't just go start like scratching them out. What you have to realize is think about all those factoring rules. What's the GCF we can pull from the top? An h, right? So what we can pull out is an h, and what will that leave us with? 2x plus h plus 2 all over h. Is that okay? All I did was factor out, because Corey's right, they will cancel out, but a lot of people start canceling out when they shouldn't. So technically why canceling out works is because you're factoring out a common term, and that common term you're factoring out in front will cancel with the one on the bottom, just like these h's up top will cancel. So I pulled an h out of the 2xh, so that just left me with the 2x. I pulled an h out of h squared, that left me with an h. And then I pulled out a 2h from there. So the h's will cancel, and you're just left with, let's just write it kind of in order, 2x plus 2 plus h. I know, right? I'm about to hit my time. Okay, just in a nutshell, the shortcut for derivatives, the main rule is called the power rule, meaning if you go and look, and I'll erase my print things here. The power rule means bring down your power in front and reduce your power by 1. So if we bring the 2 down in front, you have 2x, and then you reduce your power by 1, that just is x to the first. Notice we have 2x there. This is just a power of 1. You bring him down, 2 times 1 is 2, but if you reduce his power goes to 0. What's anything to the 0 power? 1. So the variable disappears, and it just leaves you with a 2. And that kind of the same thing works up here. Like I said, guys, if you don't get that, that's fine. That's calculus. But we are learning calculus, but you only do this for the first section or so in calculus. But then the rest of calculus is showing you shortcuts where you don't have to do the difference quotient every time. Okay? Just like we knew the shortcut for 5x minus 1 was just 5.